RBS Business Research Academy welcomes to you in the lecture number two. So this lecture number two is basically about the understanding some technical details about the two-stage approach. As already I told you about in the lecture number one, that the two-stage approach is basically involved the two different approaches. One is the artificial neural network, and it is a two-stage approach. So there's a combination of these two approaches. That's why we call it a two-stage approach. So some technical details which are very important for us to understand before applying especially the ANN network. So let's start to discuss these technical details. But before this one, my name is Dr. Rainbek Sumro and I'm working as a professor, Shah Abdul University, Pakistan. And if you want to contact with me, then these links are available through which you can contact with me. So some technical terms. So first one technical term is about the algorithm. You know, this is the all the software basically they are running some algorithms are there. So whatever the two algorithms are available. So in this the two algorithms are available. The first one that's about the multi-layer perception MLP and the radial basic function. So now in this regard, the mostly what I have is observed that the MLP has been used. So differences paper they've used the multi-layer perceptions. So that's why we are focusing more on the multi-layer perception because hardly someone has used the radial based function. The only the good thing of the radial basic function is it is very fast. If you compare this rate RBF with the MLP, the RBF is the easier and the faster than the multi-layer perception, but the performance of the MLP is better than the RBF. So that's why the most of the researchers they are using the multi-layer perception. So now the multi-layer perception produce a predictive model for one or more dependent target variable based on the various predictor variable. So now basically we are providing the dependent and independent both to the multi-layer perception algorithm, and depending on this one it creates a some the results to us. So it creates several layers, and that's why it is a slow. The problem with this one that it is slow because it is so many layers. So that's why we call it is multi-layer perception. So in which what the three layers are there. One is the input layer, another is the output layer, and the third one is the hidden layer. So that's why the maximum paper are available on the MLP. So because of the usefulness of the MLP, so maximum number are available. Number of the papers are available on the MLP. So now in the MLP, the dependent variable can be nominal and ordinal or scale, whereas the predictors can be categorical or the scale. So now algorithm. For example, here a loan officer at a bank needs to be able to identify the characteristics that are indicative of the people who are likely to default on the loan and use of the characteristic though to identify the good or bad credit risk. So now for example, any bank officer wants to know about the characteristics of those people who are defaulters or who may default. So if the bank officer want to identify the credit risk, then this technique, this algorithm can be used. So using the sample of the past customers, she can train the multi-layer perception, validate the analysis using the whole out sample for the past customer, and then use the network to classify the prospective consumer as a good or bad risk. So based on the previous the experiences and what will she will do? That she will provide some past means the data of the past customers and to this is a predictors. So then this algorithm what it will provide to the that means a different predictors and the from the importance point of view. They means which predictor is the most important, which is the least important, which is 50% important, which is 70% important. In this way, the predictors will be ranked according to their importance. So then the loan officer may decide that if any customer is carrying out this the predictor or this type of the like we get the indicator. Now their customer may or may not be provided any loan by the bank officer. So now, uh, algorithm, basically there are the algorithms are there. For example, here three type of the other. One is a standardized. Now it means to subtract the mean and divide by the mean deviation. Okay, and then in normalized, subtract the minimum and divide by the range. And then normalized value is fall between the 0 to 1. And adjusted normalized are there. Adjusted versions of subtracting minimum by dividing the range. And then none. That means that if you do not want to provide any rescaling of the covariates. So now, for example, here you're looking at these are four type of rescaling covariates are available there. So in this way, you can rescale. So normally we use the standardized. Okay. Then here, both are supervised. Both they means the algorithm. This means algorithm MLP and the RPF. Both are the supervised learning techniques. That means they map the relationship implied by the data. So they will create the relationship according to the data which you have provided to them. And then you know the output, you know the input and both, and now you are asking from the computer do this one. Okay, so now we are basically providing the input data and the output data, dependent variable, dependent all the data to the software, and now we asking from the data from the software please provide me which are the important predictors are there. And then what the software will do, the software will use the feed forward architecture, meaning that the data moves only in the one direction from the input nodes through the hidden layers of the nodes and then the output node. This is a process through which this is a process of the feed forward architecture. That means that the software will feed the data to the forward, and then the first it will become the input, then the hidden layer, and then the output. Already I told you that there are the three type of the layers: input layer, and the hidden layer, and the output layer. So now we talk about the layers. So now layers are equal to the IV and the DV. The number of the neurons in the input layer are equal to the number of the input like the predictors. So now your layers should be equal to the layer of the IV and DV. Predicting the accuracy, prediction and accuracy depend on number of hidden layers. Higher than the number of hidden layers, higher than the prediction and accuracy. While the number of the neurons in the output layer are equal to the number of the output like the dependent variable. Okay. And then the third thing is the number of the neurons in the hidden layer affect the both prediction, accuracy, and speed of networking. So that's why if there are if there's a large number of the hidden layers, so now what we can expect the good prediction and the accuracy and the speed of network. That means that in other terms, we can say that if you need a prediction, accuracy, and speed of networking training, then you need more and more hidden layers. So now here, this is a one type of the graph which will produce by the ANN if you will demand. So here you are looking at this is our output layer. We can call it a dependent variable, and this is our input level. These are our independent. Our predictors are there. So these are different predictors are there which are there. And these are basically the hidden layers. So now this is a black box approach. Now you look here, this is a black box approach because we do not know what's happening over here because the software is performing this function by itself, and we do not have an approach to understand what is being happened over there, especially in here. So that's why we use the word black box. So now we know about. Then you're looking at different type of the interactions are there, our path are there, so complex process there. But we are concerned with the either with the output layer or with the input layer. And the third one is a hidden layer. And now which type of the like the we can perform. So dependent variable, you can specify dependent variable which may be scale, categorical, or combination of these two. Like the either one may be scale, one another may be categorical. If the dependent variable has a scale measurement level, then the neural network will predict the continuous value that approximate the true value of the sum of the continuous function from their input. So now, if it's a measurement level, then the software itself will identify the different options which are available over there in the input data. If the dependent variable is categorical, then the neural network itself is used to classify the cases in the best category based on their input predictors. So now, for example, male or female, 0 or 1, true or false, for example. Now, if this type of data, like the categorical data is there, then again the software will classify all these categories according to its own calculations. And then and then hidden layers contains unobserved networks, nodes, or we can say the units, and each hidden unit is function of the weighted sum of the input. And then the function is an activation function, and the values of the weights are determined by the estimation of algorithm. So now the algorithm will provide the estimation values or weights to each node or unit by itself. One more thing here. So artificial neural network is basically can be a good substitute for the execution modeling, multiple linear regression, or binary regression. So binary regression, when we have the two options in the dependent variable, yes or no, male or female, like this one. Measurement of the DV. So now we can measure the dependent variable through the error. If the R, so now this we can measure through the RMSE, root mean standard square error. So if this value is less than 0.1, that means the our prediction is good. And the categorical variable, if we want to know about the categorical variable, then there's an error we can call is a Confucius matrix table. So now we have the two dependent variable, and the one is the now we have the two dependent variable for the scale measurement. For this purpose, the RAMC value we have to take into consideration. If its value is zero point 0.1 or less than 0.1, it's a good thing. And if our dependent variable is a categorical variable, then in order to identify the error, so now we have to refer the confusion matrix table. So these two things are there which we have to understand. Some issues in the hidden layers. So first of all, the one issue is a simulation experiment indicate that to some point of the higher number of neurons in the hidden layer gives a higher estimation. It's a clear. Earlier we understood that the number of the hidden layers, if they are higher in number, they definitely will get the better estimations. But problem is this one, that the too many dramatically increase the computational model. So now the problem will be there, the overfitting. If there are so many layers are there, this layer will create the problem of the overfitting. So now what will happen is that in this one system, right, system has memorized all the data, and it may work superb on the previous data, but when the new data are given to the system, it will be difficult for it to understand. So now it can work probably on the previous data, because previous data just are known or memorized by the software, and it may face some problem when providing the new data to the software. So this is a problem. And number of hidden layers, for example, how many? For example, if it did independent variable are 8, independent variable are the 2, then the hidden layer may be from 2 to 7. So now, in order to means that to create the hidden layers, we have to we have to depend on the system to create the layers. So, but layers should be depend on the number of the IVs and the DVs. So now the range is there. Already I told you that if the range is IV is 8 and the DV is 2, the range is from the 3 to 7. The hidden layer will be created from the 3 to 7 if the total number IVs are the 8 IVs and the 2 DVs are there. And then ideal number of hidden layers. So there's no expected way. So how many ideal numbers should be there? So now no one can tell you about the ideal number of the layers to you. But so now we have to find out or we have to follow the trial and error approach. One of the most widely known empirical driven rules of thumb is that the optimal number of the hidden neuron is usually between the input and the output neurons. So now already I told you that here uh, there is the rule of thumb is there. There's no scientific rule. The rule of thumb is only that we have to depend the number of the dependent variable and number of the independent variable. For example, if the dependent variable is two, these are two, and independent variable are the say eight. So now the range is from the say 3 to 7. So from this range, the means hidden levels will be found by the software. And other some guidelines are the rule of thumbs are there. With the Shibata and Ekaido one is there, suggests that the number of the rules in the hidden neurons aim could be calculated as follow. So now here the aim is the number of the neurons. How to calculate is the aim is the number of the neuron input neuron like this one, and the number of the output neuron. So now divided by these, multiplied by the input and the output neuron, and then take its square. This is a one tool through which you can identify the hidden layers. And another tool about from the trial, that's about the number of the hidden neurons. So this is the formula, and for here the n is the number of the input neuron like this one, and the one is the number of the output neuron. So now you have to add these both one, and then deduct the one from the result and then divided by the two. So now this other one calculation, and another calculation is that you have to take the log. So like log arithmetic dependence, where n is the number of the inputs in the neuron, and propose that we have to take the log. Now Fong and Ma in 2009 proposed that we have to take the log square from this. So partitioning of the data are samples. So here we have the three options that are available. One is a training, testing, and the holdout. So the training set we use for analysis purpose. So this data a partition we have to use for the analysis purpose, and the testing data we use it for the and the testing data we use for to prevent the overtraining, whereas a whole out sample we use for the validation purpose. Okay, so now these are the three partitions of your data. Now for example here the specifying 3730 would be relatively the numbers for the uh, testing, training, testing, and holdout sample. That means the 70% we will allocate to the training, and the 30% we have to allocate to the testing, and the zero we have to allocate to the holdout stage. And for example, 211 in this means that the 50% we have to allocate to the training, 25 and 25% we have to provide to the testing and the holdout stage. And that 111 it means the 33% to this one, 33% to this one, and 33% to the house. In this way we can partition our data. But the main thing is again that the training data is our basic analyzing data, and the holdout sample is our for the validation purpose. But normally, researchers do not use this whole out set. They only provide some of the data to the training set and the remaining to the testing set. Now, for example, sometimes people they are using 7:3 ratio. Sometimes people are using the 9:1 ratio. That means 90% they are allocating to the training set, and the 10% they are allocating to the trend testing set. So in this regard, here you are looking that there is a partition, and then here this is a partition relative number and the percentage. So in the training we have now here 70% has been allocated to the training. It's 70%, and the three, that means alternately the 30% have been allocated to the test, whereas there is nothing for the holdout. So if you add these 7 and 3, it will become 10, and here 70 and 30 will become the 100%. So our data set partitions, there are basically two partitions, 70 and 30 percentage is there. And another is about the network. So another important is about the architecture. In the architecture, basically architecture is used to identify the structure of the network, how you are structuring the network. So in this way, the procedure can be selected the best architecture automatically, or you can custom architecture. You can provide the architecture by yourself. In this case, the both approaches are not substitute for each other, but actually are complement to each other. So in the architecture, though these two are possible, if you are focusing depending on the automatic, then if you place check this one, then the automatic it will take the number by itself. Alternatively, you can use the custom architecture here. Hidden layers are there. You can provide, and the activation function. If you can use a hyperbolic or Simon, then activation function is identity hyper. So these are so many technical terms are there. If you are interested to know what are the, then the PLS, then the AN menu is there, and through by downloading you can go through all these one. It's better to check the automatically. That means automatically the things will be decided by the software itself. This is the output. Output means the result which you are requiring. So now we require description, we require diagram, we require synaptic weights, and then model summary is very important. And then if we require the chart, then the predicted by the observed chart, residual chart. If you require the chart, you can also put the check over there. Case process summary is important, and independent variable important. So now this is important, this one is important, and this is important, and then description. So these four results are important. In the rest of result, these are optional. If you want to have, then okay. Otherwise, that's not a problem. And then if you want to save, then this option is available. Save the predicted values or category for each independent variable. Or you can also go for this option, automatically generate unique names. So now the software will provide unique names by itself, or you can also customize names of the your input and output layers. So here, so now, if you want to know more about this one, this is a wonderful document. It's easily available on the website. You can also download. Alternatively, this is also a wonderful document through which you can also work on this one. So at the end, thank you very much for watching this lecture number 2 completely on the two-stage approach, which involve the artificial neural network and the PLS-NN. I hope you like this video. And if you like this one, please subscribe my channel and leave the comment on my video. Thank you very much.